computer and stuff. Okay, so we made a start on the class. We're in Intro to R, and we got pretty far through. I'm going to skip the last section, which was functions. I'm going to come back to it because we're going to go into plotting in R, which is, I think, a nice session to start after 4th of July. So in Intro to R, we covered the basic data types, vectors, matrices, data frames, lists. So, you know, vectors are the very simple one-dimensional. Oh, we have factors as well, one-dimensional, but categories. We have matrices, which are our tables. But important matrices can only ever be one data type, which meant that, you know, you can't mix a string and you can't put a numeric in the same matrix. It all becomes a string or a character in R. But we came across data frames, which allow us to hold mixed data types, and we have lists, which allow us to hold mixed objects. We can have a data frame, a matrix, a vector, all held in one kind of list, and that just allows us to organize our database better. Beyond that, we looked at, really importantly, reading and writing from R. So we looked at the standard read functions, and we looked at the standard kind of write functions, but then we also came across this package RIO, however you want to say it, and that allows us to do all of it, right? It allows us to import from Excel, SAS, MATLAB, all these other data types, and you may be working in MATLAB for something, you want to come to R, this is going to make your life easier. And that was RIO. And then at the very, very end, last session, we did loops and conditionals. Okay, and we actually had a tough exercise at the end, which I'm updating, because I think we had a loop to merge files, and some people said it's a little hard to follow, so I am going to update that, and that will be in the video as well. So today, I wanted to move on to plotting in R. So this is the course, it's our second major one here. And we're going to do this session in kind of 3 parts, I believe. So the first part's a little long. We'll do that now, and then we'll do the first part of the second session. And in this first session, we're going to introduce you to base graphics. So how you can make simple plots in R using what's available without loading any packages. This is what comes out of the box in R. I don't know what's gone wrong with my first slide. Something's changed in the background. Let's fix this. And I think, you know, base R is really useful. It's a really exciting set of tools to allow you to visualize your data. But in the second session, I'm going to introduce you to ggplot. And I'm not sure if anyone knows what ggplot is. Kind of maybe. ggplot is just the winner of graphics in R at this moment. And the lovely thing about ggplot is that it allows you to make interactive visualizations using another package. So it really is fantastic to learn, but there are some potential issues with ggplot, which we're going to cover in this first one. So as always, you can get the links to the material, you can download everything, you can set yourself up in the working directories, etc. If anyone's still having problems with that, let me know. But then to get started, right? So I think R, as far as the reason I started using R, and I learned Java and Perl as like in school. But the reason I started learning R, two major things, and that's biology, bioinformatics. R had this kind of covered with the advents, the creation of the bioconductor set of libraries. But the second reason, which you get within your first hour, 2 hours of learning R, is that R really has excellent graphics and plotting capabilities. It can do an awful lot that you just can't do in things like Excel. Although, you know, Excel is pretty cool. And I think generally it's seen, and this is an opinion, I guess, we still have the guy who's Python guy here. Python guy. Maybe I'm making a statement here, but you know, it is seen as one of the advantages of R over some of the other competing languages, Python or MATLAB. I mean, Python now has an implementation of ggplot. I think they had to call it something different, so the ggplot author complained. But a lot of these things have started to try and copy the R structure, how we actually do plotting. And they're mostly found in these 3 sources. And you have base graphics, and I say base, this is just what comes when you've installed R. You don't need anything else. And then you have these 2 packages, which maybe less popular now, but the lattice package was a very useful package for multivariate data. I got multiple different groups and I want to put them all in one plot. Lattice made this super easy. Similar is actually this ggplot package, which is written by Hadley Wickham, who now works for RStudio and Posit. And ggplot is very much like Lattice, and they both use a slightly alternative system to base graphics. Okay, so base graphics follows what we call a pen and paper model, right? I have my thing I want to plot, my space I'm going to plot in, and I will do my first part of the plot, and that is there forever. It's a pen, and then I will write over that plot to add additional annotation. So maybe I will create my line plot, and then I will add a legend. Perhaps I will highlight a particular point of my plot. That is the pen and paper model. You are creating the plot one point at a time, and you're building it up. Both Lattice and ggplot actually use this alternative system called grid. And really grid, there's some slides on this somewhere. So really grid, written by this person, Paul Murrell, offers a slightly alternative to this pen and paper, where they provide high-level functions which really allow you to create a complete plot. So you're not writing the plot to paper one part at a time. You're building the plot up as an object, and then you're writing that to the paper. Okay? So that has a lot of flexibility, and we'll see that later on. Okay, and we'll see that in ggplot. So grid is the base for both ggplot, which I have here, really popular package, and we'll show you its popularity later on. But also like this lattice. So this is an example of a lattice plot. And really lattice is the package which does this phenomenon called trellis graphics. And trellis graphics, as I said, is just built for multivariate data. It allows you to break up your plots. Like here, you may have different groups and different subsets, which you want to plot in different panels. Lattice allows you to do that. So does ggplot. But it's an alternative to what we're going to cover right now, which is our base graphics. So like I just said, once a plot is produced, you can only add more elements. You can't remove. This makes it harder to update. So if I already made a plot and I just want to change one thing on it, I have to remake the plot. I'm going from basics. I go back to the beginning. If my line was, say, red and I need it to be yellow, I redo the plot, and now I put in a yellow line rather than a red. Okay. So that makes it very hard to update. And again, ggplot and these other things, you're going to see how flexible they can be, but it also makes it much faster. Much faster, it makes it faster than other plotting systems. Okay, so by writing to the page, we're not holding lots of things in memory, we're just holding what we're writing to the page one at a time. So with things like Lattice and ggplot, they're going to try and build the whole object before they write it to the page. And that flexibility you gain there, you lose in speed. Okay. So that's not going to be a problem for any of the data we're handling in class. It's going to be instant. When you start to do with genomics data or big data, ggplot's going to be slower. And there will be some functions in base plot you just want to go back to. And most likely the major one is box plots. They are super fast in base graphics. They're pretty slow in ggplot, although ggplot is getting faster over time. Things like box plots, histograms, and just line plots, dot plots as well. They're just quicker in base graphics. So we're still going to cover base graphics. So we're going to start kind of basic here, step through this session. Okay, so the first thing we're going to need to produce any type of plot is some data. So here we're going to produce a vector, and we're going to call this treatment. And we've covered this already, but we're going to create a vector length 1, 2, 3, 4, 5, 6. And we can combine our numbers into a vector by using C. So combine, and then they're separated by commas, and we have our vector. If I want to start making plots in R, we have this really flexible function called plot. And this is going to take lots of different arguments. We'll work it out over time. But if we just give it our vector, we can already see it's doing something useful. So I'm just giving it this value here. And if I do plot, remove this. I'm recording, okay. If we do plot, we can see we have already it's built us kind of a frame, right? It's built us the box to put all the data in. We've got on the left the actual kind of axis for our values within our vector. And you can see it's already called that axis treatment. So it's actually taken the vector name and used that as our axis label. And then because we don't have any other values, we're just giving it one value. Along the bottom here, along this axis, we have the position within the vector. So the actual index. So the first position have that score up until this score here. So it's basically plotting the values in our vector versus the position within our vector, and it's given us the box and it's given us the labels on the side. So there are a lot of ways we can customize plot. And one of the first things we can do is the different types of plot we want to do. So here I'm going to do, I think, an O plot, which I think is an overlay or an overplot type of plot. And if I just, all I have to do to create this versus, no line is to change the type to O, and we'll get an overplot. Okay. Not much else we need to do there. And we have a list or a set of different types of plots we can do. So if we just do plot, treatment, and I change the type, I can just do a line plot, right? Maybe I don't need these circles. I can just do a line plot. Or here, if I want to do a point plot, I can do type equals P, and I'll do a point plot. We have a lot of options available to us. And as I hopefully shown you, if you want to know the options available to you, best thing to do is to do question mark and the type of function. So here we have question mark plot. And we can see we have, I've got, actually, because I've loaded to something else, I have another version, but I have base graphics, generic XY plotting. And we can see, as before, it's given me like a description of how this works. We have the usage, we have the arguments it requires. So we're just giving it the X. Okay, so it's going to give the coordinates of the plot. And then we have the type of plots we can do here. Okay, so if I want to know what type of plots I can do or more about this function, question mark plot, and I'll bring this out. So I have P for points. O was actually overplotted. And then lines, both histogram, stairs. And in fact, there's a option here, N, which will just produce an empty plot. Okay? If I just want to have the box and the range of the plot, I can actually just say N, and I get nothing plotted. Okay. So plot, very flexible function, but we want to be able to make very obvious updates. So in this case, maybe we just want to add a title to our plot. The plot function has an argument main. And if we give it some text here, a string, it's going to give us a title to our plot, very simple. If I give it a sub, it's going to put here underneath our whole plot, it's going to add some more kind of subtitle, but not necessarily a caption, just a subtitle. We can actually update also here. So by default, it's taken the name of my vector treatment and the index here. If I want to update them, I have control over the xlab and the y label with these functions xlab, parameters xlab and ylab. Here, I'm just going to say xlab is the position. So now I don't have index, I have position. I can say the ylab's score. I have score here as well. Okay. So already we can add some titles to our plot, and we can update these axis labels, and we can make at least a very simple plot very, very quickly. One thing which is kind of a pain to people is the orientation of these axes here. So by default, I don't think I really like this. I think it's not super easy to read. Zero is kind of pointed towards the axis on this way here, and then a little bit better orientated at the bottom. We can control that actually with this last argument. I'm trying to think what last stands for. I'm not really sure. But we can do plot, and we can say last equals 1, and that's going to set then our labels to always be kind of this orientation with the axis, which I think is a little better than this. Or if we don't like that, we can also do last equals 2. And then the axis will be rotated for the bottom ones. And if we want to see a full version of this again, exactly what we can do, we should be able to come in here and go through either this function or the par function. That's it. And it will give us a description of all the options we have here. So 0, always parallel to the axis. So that was the default. That's what we saw. 1, always horizontal. 2, always perpendicular to the axis. And then 3, always vertical. I'm actually not entirely sure what all of that means, but you can just play with the options until you discover which one. So again, here to find some help here, I just did question mark plot. And that brought up the original help. And then it told me here for more details about graphical parameter arguments used by traditional graphics, follow this link. And if I click that, it's taken me into a really nice description of all the different parameters which are available to us. So already we can see, we saw LAS, but we also can see this one, which is our next thing we're going to do, which is our character expansion. So here, if I want to make my points bigger, so I can change my types of points using things like type. I can orientate the axis, but if I want to make the actual points bigger, I can use this character expansion ratio. So I can make them twice as big by setting CEX to be 2. But if I want to make them half as big, I can do CEX to be 0.5. Just a note, these arguments are going to be used in lots of different plotting. So character expansion, CEX is a really common parameter for plotting. We can also control the types of points in our plots. So if we're not happy that we like I think actually this one is a bit of a pain, these kind of open circles. If I want to make this into a closed kind of dot circle, typically we'll use this PCH 20. So that's the type of point we're going to use, point character. And again, if I want to know all the available point characters to me, let's have a look-see. I think it's probably in here. What was the argument again? PCH. So if I want to search within this thing, I can do PCH. Okay. Either an integer specifying a symbol or a single character to be used. So I can actually put a character there, an A, C, and that will be the positions of my points. And other people. You can see here it's actually sending me down to another function. So I click points. And here, finally, we get kind of a description of what all the characters are. So you can get stars, pentagrams, all sorts of good stuff, and then various ones there too. I'm just hopping into the help so we can see how we can find out this information. Because we don't have time to go through the information here, but it's readily available to you. So we can make lots of different types of points. We can also control the lines as well. So if we're going to make line plots, which is what we're going to do a lot, we can control this with 2 functions. And the first one is LWD, which I think is line width. So here I'm going to do my plot. I will set the treatment to be our vector. I will give it our type. So I'm going to say line. And now I'm going to say line width. And it's like the character expansion parameter. This is going to expand my line 10 times. So now I have a nice thick line. In this case, we're going to do LWD is 0.5, which is going to like make my lines half the size. So we can control the line width, but we can also control the line type. And often you'll want, say, different types, classes done by different types of line, a dashed line, a straight line. So we can do that again with this LTY parameter. So here, if I do plot and I give it treatment, I can say I want this type of line. I want a line plot, but then I want this type of line. So I think by default, 1 is a straight line, unbroken line. But then if I do 2, I'm going to get this kind of, I think this is a dashed line. So again, we can look up where we found that information if we don't know what type of plots. It's not going to be in the points argument. So let's try again from here. Do we have LTY in here? Nope. So it tells me to go to par. So I have LTY in here. Okay, so there's my LTY description for what 0 blank. Not sure why I do that. 1 is solid, 2 is dashed, 3 is dot, 4 is dot dash, 5 is long dash, 6 is 2 dash. Okay. You can also provide, I guess, rather than a number, you can actually provide a string directly specifying what point. Okay. So I think one of the other things we can do, which is obviously super useful, is update the colors. Okay, so for whatever we're plotting there, we may, if it's a point plot or if it's a line plot, we may want to make the points a particular color. We may want to make the lines. So we can do that really easily inside R by just doing col. And here we can do red. So most of the default, I've got a slide to show you this now, but most of the colors you can think of will be somewhere encoded in R, the basic colors, green, yellow, red. Okay. And then on this one, I've done Dodger blue. It's because my old boss is a fan of the Dodgers. And every plot in every package he ever wrote uses Dodger blue. It's actually a really nice color, so I tend to use it myself. But for some reason, there must be a Dodgers fan in R because they built Dodger blue into the base R. Okay, so there is a really extensive, and I think Matt's added a nice slide later on we'll come to about palettes. But in basic R, this was created obviously by this guy. Oh, someone in Colombia, just up the road. And we can see we have lots of different colors, including things like white, burly wood, orange, Dodger blues, a whole variety of Dodger blues. See, I don't know why. Grays, hundreds of grays, lots of different types of cyan, as I remember as well, ivories. So, you can choose your color from here, seashell, and all sorts of stuff. You can choose your color from here, but you can also, in R, and we'll show you this in a bit, make your own colors up, right? It's an RGB. We can put any type of color we want in. And what's really cool is that there are tools out there to allow us to build palettes. And we'll come to this later on. But, you can actually get things like the Wes Anderson color palette for your plots, right? It's all, someone's thought of a different color palette already there. Okay, so I've done this as we've gone along, but there are a lot of options for plotting, right? Question mark plot will give you the first level of options related to plotting, the basic parameters you need. And we saw when we looked in question mark plot, these are very well written help pages, and this is another reason why R is so cool. Well, my computer's starting to slow down with the recording. Is that here, it's very well written, and it's actually telling us where else to go look for more information. So it's not all on this page, but it's going to tell us. Go to par, and then if we found out what we needed to know there, we can, this may have another link, and I think we saw it took us to points somewhere in here, to discuss, or text. But it should, if you follow these manuals and you follow these references, it will tell you through every option you need for these points. I can feel my computer starting to slow down with the recording, so I might stop hopping back too much. Maybe new computer. So the plot function, I say it's really flexible. We're not even going to cover the degree of flexibility within this plot function. But one of the useful things, and I think one of the things where base graphics wins over some of these complex grid graphic systems is XY plots. Okay, so this is super fast, way faster than we're going to get in other tools. So still, it's R, it's not going to be as fast as, say, C or C++. But we can do simple XY plots just by giving another vector, and here I'm going to provide control, okay, and then we can do a plot, and I just provide two vectors. Okay, so we saw that when we did question mark plot, it can have an X and a Y. And we can see here that it plots the first argument, the X, along the X-axis, and it will plot the second argument, Y, along the Y-axis. Okay, and it's done again, something very simple for us. It gave us the treatment. Sorry. Move that about. They put the label for the treatment, the actual name of the vector, and let's put it there. And let's put the name of the vector we passed in from there, and put that there. That's great. One thing I want to point out, what it's done for us, and I kind of forgot about this earlier on. When we make this plot, I'm not saying anything about limits, how big the plot should be. Right? It has built the plot. It knows from the data, okay, the maximum value of my y is 100, maximum value of my x is something like 80. So it's then built me a reasonably sensible axis where it's going a little bit above 100 and a little bit above 80. To cover and have all the data in this plot. Okay, so it's done that under the hood. Okay, so now we're going to start to get to the pen and paper part. Oh. I think we're about to show you. So yeah, exactly with the pen and paper is you can. Oh, when you say a third vector, do you mean like a third dimension? We can. We're not going to cover that here. We're talking about 3D plots. We can. Personally, I'm not a big fan of 3D plots, but absolutely we can. That's something I should add an example of. So I'll add an example there. Because when you get 3D, you tend to want to also be interactive. You kind of want to rotate it as well. So it's not going to be covered in this basic course, but I will add something in it, so we can certainly do it. There are special packages to allow us to do this. I'm trying to think of in gene set enrichment analysis when you get a third. Oh, no, that's different from 3D. And that's going to be ggplot. And that's great. Yeah, that's perfect. You can also do that here, but you're going to see why that's so much easier in ggplot later. So sorry, that was a good question. So let's say you have a third vector, and I want to make, or a third thing to overlay on this. Say I know that some of my points from a bigger sample size, and I want to make the points bigger. That's a good question. That's covered in ggplot. You can do that in base R, but as you would see, you'd have to kind of build the routine to do it yourself. ggplot will show this. That's a great question. So we're going to cover that later on. So in this case, we're going to try and add, and this is probably going to show a little bit why this would also be harder than base graphics. At this point, we're going to try and add a line to our plot, a second line to our plot. So we're going to use here a slightly different setup. We're going to do plot. We're going to give it the treatment, but we're going to ask it to plot treatment versus the position in the vector. So our control is the same length, right? It's also 6. So we're going to have the same number of positions along this axis, right? So I can do plot treatment, and I can say type equals O, color equals blue. And I get my plot. Great. And the blue line looks good. Everything's in. So now I can add to this plot, following our pen and paper model. I can go lines, and I can do control. So I'll take my control vector now, and I can do lines, and this will add a line to the existing plot space. And lines takes very similar arguments. Obviously, it's always going to do a line, but I can say type equals O. I'll get overplotted. I'm controlling my point size, my point type, so I'm going to make it 22, which is now going to be squares. My line type, I'll make it 2, so it's going to be a dashed or something. And I'll do color equals red. Okay, so we've got our 2 separate data vectors now plotted side by side with the index. Okay. But we can already see an issue. Okay. This line here, which looks pretty linear, just goes off the side of the graph. Okay. So this is a pen and paper problem. We'd already written the graph, right? We did plot, and that created the plot for us, and then lines was in that plot. Okay. So in order to make this actually fit, I'd need to redo the plot. Okay. So then what we can do is hopefully very simple, is we can just make sure that we include y limits and x limits, which will include all the data in our plot. We just need to do it up front. Okay, so rather than grid graphics where it calculates the whole plot and then puts it on the paper, because we've already done the plot, the space in that first plot function, adding lines to it isn't going to work. We need to create a sensible here y limit, and we're going to say, okay, the highest value in X was 100. So let's put the Y limit 0 to 100. And now you can see it's made again the treatment axis here, the Y, but it's put it up to 100 and a little bit more than 100. It never just cuts off at 100, a little bit more. Right, and now we can see with the same lines function, we can see that we actually get this nice kind of plot. Okay, so we can do that a little bit more dynamically using this range function. So let's say, I mean, here I can look at my data control and I can see what the top value is, right? But let's say you have 1,000 values there. You want to pull out the top values from this programmatically. And in fact, you probably want to pull out values from multiple vectors programmatically, right? Now, if I'm plotting lots of things. So we can actually use this neat little function range. And range takes any number of vectors, so numeric vectors. So here I'm going to provide 3. And it's going to find the minimum and the maximum values in that. So the range of the data provided. Okay. So I'm going to give it treatment. I'm going to give it control. And just to be sure that I start at 0, I'm also going to give it 0. Okay, I know actually if I look back now, control also had 0, so I didn't need to. But maybe I didn't know at the time, so I'm going to put 0. And then really what this is going to give me is the range from 0, unless there was a negative value here, perhaps. It's going to give them a range from here to the maximum of any of these vectors. And in fact, what it returns is a vector, numeric vector of length 2, where we have 0 and 100, which is the minimum and the maximum. Okay. So now I can provide to our plot function the minimum and maximum, this G range. And if I go back a few slides, we can see here, we provide to YLim a vector of length 2, the minimum and the maximum of that Y limits, the Y axis. G range, this function range, returns a vector of length 2. It's perfect just to give that straight to our function, and that will plot the data with our new ranges. Okay. So I'm actually going to probably just run that quickly inside R, if I can get outside this. I don't think I don't have a control treatment value yet. So treatment. Oh, that's interesting. I'm plotting onto a plot I already had on the page, so I didn't delete it first. So I'm going to set my treatment first. Let's do 10, 55, 65. Then that actually worked kind of nicely. And then if I wanted to, I can do, what was it? Plot. Oh yeah, sorry. Range 0, treatment, control. Okay, so then that would give me the ranges of all my data. And if I wanted to actually redo this plot here, I don't need to supply this hard-coded values for YLim. I can actually provide here, actually I could provide directly this function. So that's just to allow us not to know up front what the limits of our data is. We can use this range function to calculate it. So actually now I think in these next few slides, we're kind of going to go plot by default. There's a really sensible, it gives you the boxes, it gives you the axis, everything. But we're going to show you kind of the anatomy of this. We're going to build it up a little bit ourselves. Okay, so hopefully there's good reasons why you might want to know this. And it's just because you might want to customize kind of your plot to maybe only have one axis, maybe just along the left. Maybe it doesn't matter about the y-axis so much, or just have a title, maybe no axis, no labels, just to confuse people. But you have that level of control in plot, and you can build up all the elements of your plot using separate functions. You don't need to just run plot with default. So let's have a look. So here I'm going to take that treatment vector again. I'm going to give it an O plot. I'll give it color blue. And I'm going to say the Y limb is the range we calculated previously from this slide here. So I know it will contain enough space to include both the control and treatment data. But I want to get rid, just to demonstrate here, any annotation. So the labels, the titles, the axis labels, and I actually want to get rid of the axis itself. So I can say axis equals false and equals false. And that turns off, and it actually makes a kind of useless plot, but hopefully we can see that it's the plot space with just the line within it. So the first thing we can actually add to our data is an axis. So we can use the axis function here. And this also gives us a little bit more control over how we want to lay out our axis. So in this case, I'm going to do axis. I'm going to tell it the side I want to work on. I think it's 1, 2, 3, 4, I think. But we could do question mark axis, and it will tell us how to correspond the right number for the right side. And importantly, I'm going to tell it where to put these ticks in my graph. Right? I might not want every value to have a label. For whatever reason, aesthetically, I may just want the start and the end, or a start in the middle. So I can say put values here. I could put maybe more ticks in as well. Right? Put values at 1 to 6. Okay, so it's going to say the values from my treatment vector, which corresponded to 1 to 6 on this side. So in the index. So this is the first position, the second position, the third position, the fourth, the fifth, the sixth. And I'm going to say, these are the labels I now want at these positions. So I want Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And now we can see we have our one axis. It's on the bottom because we put side equals 1. We have ticks at the first, second, third, fourth, fifth, and sixth position within this. And then these labels are what we then put there. We can also then put in our other axis. And here I'm going to say side is 2. And then I think I was right. So side is on that side. Side 2 is on that side. And we're then going to create, I can set the last, so the orientation. So I think 0 by default would have been 20 going that way, but this 1 is now parallel to the axis. And then I can say the positions, where do I want to put the ticks? And I can use this function seek. So we should have seen this when we were creating vectors earlier on. And I'm going to say go from 0 to the top of the range, right? Because this G range was a vector containing the bottom and the top. And I'm going to say do it in steps of 20. Yeah. So now I can really customize where my points are along my axis, if I wanted to. Okay, I could actually, I don't know why, but I could have put G range 2 here, but I could have put G range 1 here, right? It's G range square brackets 1, because that would have been the minimum. So I don't know why we put it. Okay. So we're starting to build up our plot. We have our lines, our actual values. We have our space. We know will contain the full scope of our data because we set the range to be correct. And now we're adding our labels for our axes, our custom axes. You can see here we do have, so there are different components. The axis is different from this box, which goes around the whole plot. So it just is. So you can have an axis like this. If you want to make it more kind of base, if you put box, right, you just type that in, it's going to put a box around your graph. So pen and paper, just going to put it on and attach it to your plot. Okay, so now we can't really tell the difference between the box and the axis, but we saw that they were kind of separate components. So now with that plot, we can now apply this lines function, like we saw previously. I'm going to set the line type to be 2, the type of point. So I'm going to do overplot. So the point character, I'm going to be 22, which is a box. And I'll set the color to be red. And now we've built up our plot. It's the same plot now, kind of, I think. Maybe not. No, we have different labels. It's the same content, but we've kind of built it up from scratch. And we have a little bit more control of the axis and generally the look of the overall plot. So another thing, which actually I think base graphics does kind of well, is legends. Again, you're going to see ggplot later, just how much better, easier ggplot makes this for us. But right now, if we want to add a legend to try and describe, sorry, yeah. Yeah. Why, you deep into a plot and now. Yeah, it's done. You're not getting rid of that box at that point. Yeah. And again, that has real advantages in terms of speed, which we can't just throw away base graphics. You're going to see ggplot later, and you're going to want to throw away base graphics and never ever use it. I promise you, it's just faster for simpler plots. So we have this thing legend, and legend allows us to add just a legend to your plot somewhere. And it takes a few arguments, and the first argument's kind of interesting. This first argument can either be like a description of where you want it in the plot, so it can be top left, top, right left, top right, whatever, bottom, whatever. So you can just give it positions within the plot, like general areas. But you can also give it a vector of length 2, and that will be the position within the plot. So if I wanted to say put it on Wednesday at 60 or whatever, I could do 360, and it's going to put my legend in the middle at that particular location. Often this is good enough just to put top left, top right, bottom right. We then tell it the values, and that's a legend parameter. We tell it the legend, the actual values we want to put in the legend. And here we're going to say treatment control. I can tell it the colors. So I'm going to say here blue and red, because I know that corresponds to the colors I laid out. Right? It's not learning this from my plot. It is me remembering that's what I set the colors to be. I'm going to say the PCH again. Hopefully that matches what I actually use, 21 and 22, and then the line types 1 and 2. Okay. So these things like PCH, LTY, and color control what we see here. And this legend bit controls the actual legend, so the actual text beside it. But I have to make this color PCH and LTY match my actual parameters I used for the line and the plot. So I'm doing that myself just to make sure that it all corresponds. And I guess just as is added to this, we might want to also add or differentiate this by using thickness. And then just to see that in one line, what that actually looks like, we have plot, we have axis, we have box, we have lines, and then we have the legend, where we add all those things we just described. Again, plot actually got us a lot of the way, and we could have also controlled the axis labels from there, but just to show you building up. Okay, so this is from our colorblind member of the BRC, who often tells me off for my plot types, and he's right to, because I tell you, plot colorblindness is very common, and a lot of people don't really know they have it. So the people may struggle to read your plots without you having any understanding why they're struggling to read your plots. Okay, and it really is one of the most undiagnosed visual phenomena in colorblindness. So they say it's 4% colorblind. In white males, this rises to 10%. I don't know why we've added that particular part of this. So in the demographics in science, you're likely to meet someone, but that is a high percentage. If you've got a room of 20 people, it's actually kind of high. So we have, luckily, lots of palettes available to us which just cover colorblind. So you don't need to think about it. You just need to deal and use a color blindness safe palette. Okay, and one which is really useful is Viridis. If I click here, it's going to take me to the actual place. So they have a whole description of why their color palettes are great and all the things you can use there. So Viridis is a package. So there are lots of packages which will contain pre-built color palettes for you. To get access to it, I just need to do install packages, and I can say Viridis. It will look it up from the CRAN repositories where all our packages are, install it, and then I can do library Viridis to load it, get all the color palettes and the functions available to me. And then if I do Viridis square brackets 5, it's going to give me 5 colors from that palette, which are all separate, distinct, and colorblindness friendly. Colorblind friendly. Yes, some of them are hidden by underneath the actual color here. So we can see this one's this color, that's another color, that's the other color. Okay. There are often, so, you know, I'm telling you how to visualize the tool, right? But there is a lot of which goes into actually making a good visualization. We're not really going to cover that so much now. I think ggplot will allow us to do a lot of this. But, you know, just some very general things, you know, is it easy to digest? So not everyone's going to look at your plot and automatically know everything about the data. So you really need, you can use tricks to try and make the part of your data, which you really want to excite them, kind of stand out. Is it engaging and appealing? I'm not really sure. That fits us more like if you were writing a newspaper. This is really important, is do not have anything superfluous in your plot. You can make some very pretty plots. You can add some really cool color schemes. Just remember what is essential in your plot. And is this the best way to tell the story? If I'm doing a line graph, maybe it'd be better if I did a box plot or a bar chart or something else. A really good resource, and we were using this quite a lot back in Cambridge. Like, there's a really good resource for us as bioinformaticians to look at, and just the style, how I should put together a plot. So this is the fundamentals of data visualization, and it's really useful, almost just to give yourselves an idea of the types of plots you can do. Just to coin what you were saying earlier, don't go 3D, but that's not what you meant. But, you know, actually do go 3D if needed. Don't follow the rules. There are lots of really cool visualizations. It's just 3D without interaction, I think is the thing. Okay, so that's just a reference if you want to go and look a bit more into how you should do your visualizations. But we're going to have examples as we go along in this class, which is the way I believe you should do a visualization. And from this point on, and in every other lecture, the exercise is going to involve doing a plot. So we're going to learn this as we go. Okay, so I've said base graphics is fast. And then there are some functions which are written and come with base graphics which are worth knowing about because they're still faster than using the ggplot or the lattice. You have to do a speed test at some point, but I can tell you from my experience that's very true. So we're just going to cover now some of these different types of plots we can do, different specialist functions. I'm not going to give you a full selection. This isn't everything, obviously, in base, but are the ones I think you're going to want to use. So we already have our vector we've created. We've made a line of it. Okay. A really useful plot in R is bar plots. Not necessarily dynamite plots, but bar plots in this case. And to make them is really easy. We just use bar plot. We just give it the same vector and it goes and does the work for us. It's given us a axis here. It didn't give us an axis at the bottom, right? But then we have our points, but now rather than being just a point, it's actually a bar. If we want to, we can add names to this. We can actually put something on the bottom. So previously we set this to be Monday, Tuesday, Wednesday, Thursday, Friday. I can do that again just by setting the names arg in my bar plot, and I'm going to set that just to be the days of the week. Here I'm just going to give it a vector of all our days, and now my x-axis has now got sensible names. To get the same effect, I mean, I think treatment was a unnamed vector. It was just a vector, no names. To get the same effect, we can actually just do names. We can just name our vector up front. If I give it names, so that we have Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, we'll actually, those names from our named vector get carried into the plot, and they're used as our axis. So it does something quite nice for us there. If we actually give it a vector with names, it's going to use those names in the plot. Okay, so I think probably the really useful thing about bar plots is working from matrices. So here I'm going to read in some data. Actually, I probably want to read this in just to have a look what it might look like, or maybe I'll just, I haven't downloaded the material. But, so we're going to read in some data. It's meant to be tab delimited. So I'm going to read it in tab delimited separator equals question mark. It's not tab delimited, it's a question. It's CSV clearly. Header equals true. So it must have column headers. And then I'm going to say the row names are in the first column. So say row names equals 1, and that will read this into a data frame for me. Once I have this data in a data frame, I can then actually plot it really easily again using this bar plot. I think, to be honest, I'm going to have to go look at this data so we can get an understanding what was in the data I'm reading on. So it's, sorry, my computer's really slow. Oh, lots of questions on this one. Code. Sorry, it's going to take me like 30 seconds or 40 seconds to navigate this. Cool, so this is the data we're working with. So we have data frame, have column headers, day treatment control. We actually have a column which is character. And we have these two which are numeric, so values. So the reason I guess then we read it in and we can skip the head, we can skip that first column, row names equals 1. So that means we're going to have a data frame which is all numeric. Right? That's important because we're about to turn it into a matrix. And I think we saw this as dot matrix way of turning different objects into other objects. We saw as dot character, as dot vector, as dot list, as dot data frame. And in this case, we're going to turn our data frame into a matrix because bar plot wants a matrix. So if I give bar plot our matrix, what it's done is it takes our columns and it puts each column in a separate kind of bar plot. And then it stacks the values from bottom to top within there. Okay. So now we have what is called, I guess, a stacked bar plot. I actually think that's not super useful. But you can change that into suddenly a very useful plot by just doing beside equals true. And now we have our kind of two data sets kind of side by side. So we can actually see how they changed over time. Which is almost like it's broken it up into two kind of grids for us. So it's kind of multifactorial part of it. And we can control, like with plot, we can use very similar arguments to control aspects of it. So if I want to give it a main, a title, I can provide to bar plot main, give it a title. I can also give it a ylab here. I'm going to say total here on the left. And then I can also give it a color scheme. So here I'm going to say colors, and I'm going to give it 6 colors from the Viridis package, and it's going to use those 6 colors to color in my 6 values. That's brilliant. I can then, because this is a standard base plot, I can then on top of that, it doesn't matter, it's bar plot, I can then pen and paper, put on top of that our legend, and I'll give it top left here. I mean, there isn't much of a top left to fit in, so it's just kind of leftish. But then I'll give it Monday, Tuesday, Wednesday, Thursday. These are my values for the legend. Here I'm going to control within my legend the character expansion. So I realize my legend is going to be a little small space. So maybe I'll make my characters in there smaller. So I'm going to make them 80%, 0.8. And I'm going to put fill. And fill's kind of interesting because it's going to give me a box. And it's going to give me a box full of these 6 colors, which are the same 6 colors I gave to my bar function. Okay. Yes, please. I think that's generally. I know exactly what you mean. Like you have a track, and then this is whatever it is. I don't think. Let me research that a bit, but generally we get kind of told off for using these graphs. I know they're used, and they're actually kind of acceptable. But no, I think what you can often do in R is you can have like the max for a point, and you label them as like off the top. They usually sit along the top, and you give them the actual value. But I'm going to research whether or not we can do that. I don't think it's easy, but I'm sure we can. Okay, so another thing which is really, really common tool to use is a histogram, right? We want to know, given thousands, millions of data points, how is my data distributed? So we can use, again, this function, very easy function, base graphics, hist. We just give it a vector, and by default, it's created a histogram with a set of bins. We haven't said anything about how the bins are arranged. We haven't done anything. It's just broken that up for us. It's told us we have 3 values within the bin 0 to 20, 1 value in 40 and 60, and then 2 values. It's not so useful for our vector, but if you have thousands of points, this is going to build you your distribution of points as a histogram. Which is essential for looking at distribution of your data, where you should place cutoffs. Histogram is really useful. So we can do customization. I'm going to hammer this home a little bit. Just like other plots, all these plots take the same base plots. Are going to take very similar, if not identical arguments. So in this case, I want to control the color, and we go light blue. Do col equals light blue. If I want to control the y-lim, so the axis on the left, I can also control that in this plot. And I just need to give it, like with standard plotting, the range I want to do from 0 to 5. Okay. If, in this case, I want to control the title size, I can do cex.main, and that's going to do the character expansion here of the main, the title. And it's going to make it a little bit smaller. Something we actually probably do want to control maybe in ourselves is breaks. Okay, so by default, this broke our data into, and it calculates a value. I'm not off the top of my head know how it does it. But it calculates roughly how many breaks you would probably want from your data. But we can just hard control that. We can actually set for the breaks argument the total number of breaks we need, and here it's going to be 2. And there it's going to be 10. And you can see this already gives us a lot more resolution. I mean, the one on the left is useless, right? It doesn't tell us anything about the distribution of data, but just by setting it to 10, I can see that actually there's a lot of value in the strings for whatever reason. So hist, another very quick function. You can imagine you could just pass this columns from a massive data frame or a massive matrix, and it will give you the distribution of data. I think we have 2 more plots, and then maybe we'll take a break. It's a lot longer than I thought it was, but let's see. So another really kind of useful plot, just because it's very useful for paired data, is this dot chart function. Okay. So a dot chart is effectively going to give us kind of grouped data, paired data, so that we have this ugly plot here, but we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and they're kind of grouped together so that you can look at the control and the treatment side by side. So this is often, an example we use this to say, I'm not sure how much you know, but ChIP-seq will have a control and an input. We'll often, a test sample, an IP and an input will often have a value for the IP versus the input. It's always paired, so we always want to look them side by side. And I think in the package ChIP-QC, which I wrote, we use this plot for that, to compare various scores between the treatment sample and your input control. But dot chart actually wants us our data, our matrix, in a slightly different way. It wants it transposed. So it wants our column headers to be row names, and it wants our row names to be column headers. So I'm not sure I've shown you this yet, but if you want to transpose a matrix or a data frame, it's very easy again. We can just use this T function, and we give it our data, our matrix, and it, transposes our matrix so that columns become rows and rows become columns. Okay. So once I pass that to dot chart, the same matrix data frame we were using, matrix we were using, so from here, except I now make these row names and I make these columns. And by default, we'll get this kind of plot. And just like with other plots, we can customize this again. So actually, this is a little bit wider, so it's a little bit thing. But if I want to, I can add colors. And in this case, I have paired data. So I tell it red, blue, and it's going to circle through red and blue, applying this as we go. And I can tell it I want it to be a dot chart. And as you saw here, this didn't quite fit. Having seen that the first time I did the plot, I will then change the character expansion values to be 50%. And then all these, everything in the plot, all the text is then going to be 50% the size. So now I can actually see my text on the left. Whereas here, and I think these are different size plots, that's probably not fair, but you can see it just fits much better. I just need to make my characters a little smaller. Okay, so this final type of plot we're going to cover is box plots. And this is the one I believe is just so much faster in R. And it's the way they've written and encoded it, just works really good. So I'm not sure if we know what box plots are, but effectively they just allow you to look at the distribution in your data, see the median, max, first quantile and the third quantile. This is all represented in this box. So you can get, it also shows the mean, which is actually the middle of that box. So we should be able to get an idea of the distribution of our data and maybe lots of different data side by side by using these box plots. This, I can tell you, is the first part in any gene expression analysis. We're going to use box plots in single cell a lot. It just allows you to see your distributions between two different groups. So we need to read in the data first. We'll read in this data frame. This now is tab separated. Header equals true, row names equals 1. And if I use head, we just look at this matrix. And we can see we have our column headers. These are like samples and then on star, where's the gene name? I'm not sure. Looks like the software names. We have our gene names on the left, titles there, so our different samples. If I want to get the idea of the distribution straight away, I can just pass that to box plot. I didn't actually need to make sure that was a matrix either. I can pass that. It's going to make a box. It's not useless at this point. Quite. The distribution of the data is so tight. You can see all these dots here. So these dots are what are termed outliers. They are a certain distance from the mean, given the standard deviations. So we'll try and put these as dots. So here we're just seeing the dots, right? It's because most of the data is compressed within this tiny range, and the outliers really dominate the data. All we need to do is log scale this, and this is what you'll do for gene expression analysis, single cell analysis, TAC-seq, whatever you're going to do. Typically, the first things we'll do is log2 transform it. We can transform our data frame here just with this log2 function. As long as the data frame or the matrix is all numeric, it's going to be able to translate that no problem into the log2 values. Okay. If you have certain values which can't be changed logarithmic, it will put either an NA or an NA. Here we're going to then put the YLab. I'm going to say this is log2 expression. I'm going to set my colors, red, red, blue, blue. And we can see then, really these data sets look reasonably equally distributed. Once we've log normalized them, we'll probably do some normalization or something later on, median scaling. But this is a first pass, tells me distribution of my gene expression data and how similar my groups are. way quicker in base graphics than GGB. Okay, so I'm just looking at the time. I think I need another 10 minutes. Do you mind if I continue for another 10 minutes and then we'll take a break? Is that okay? Okay, so combining plots, let's say we have two plots and we just want them in the same plot. Right? We can actually do this fairly easily using either the par function. We kind of saw par earlier on when we were digging down into plot. First level of help was plot. The second level was par, parameters. So we can use either the par function or the layout function to kind of define how we want our plotting to appear to the screen. So with the par function, I think this is the one we're going to show you. With the par function, we can either supply to this an argument mf row or an argument mf col. And we can tell that argument how many rows and how many columns we want. And then depending on if we choose mf row or mf col, when we say mf row, as we do our plots, it's going to do the first plot, and then it's going to do the second plot side by side in the same row. So it's going to work your plots by rows. If we do mf col, it's going to do it in columns. So it'll do your first plot in the top left, and then bottom left, and then top right, and then bottom. So this is a bit like kind of our by row, by col when we were filling a matrix. So let's see that in action. If I do, before I do any plotting, if I do this par mf row C22, I'm going to tell it I want 2 rows, 2 columns. And then I can do 4 plots. Histogram untreated, untreated 2, treated, treated 1. And it's going to fill one big plot with these subplots. I put my first plot there. If I'm doing mf row, it's working by rows. Second plot is there. Third plot is there. Once this, I'll show you that once this, I'm having a bit of problems with my computer, so I'll show you this in action when we actually finish and look at the exercises. So that's plotting it this way. We can also, of course, do this in a loop, so we can combine some of our information here, and I can set up par mf row C22, and then I can loop through my number of columns. I know I have 4, and for every column, I'm going to do a histogram. Now I can get the distribution of my data for every column, put it in one plot. Okay. There are other options here as well. So if you dig into par, there are some things you might want to control, and these include things like MAR and NGP. So these, I don't think you need to learn, but just for your own education, if you want to look at par and look at these just allow you to control actually the edges of your plot, how much space you have around the edge of it. Okay, so I'm going to cover a couple of these customizations. One thing which a lot of people kind of want to do is add some text to the middle of their plot. You might want to add, this is my favorite part of the plot. You can do that in R really easily. So once we've made our plot, and this is our XY plot, plotting control versus treatment. If I want to add some text to this, I'm going to do the text I want to add. This is my plot. Color red. And then I'm going to say the position I want to put this. I'm going to put it at 2060, 2060. And the center of that will be the center of where my text is being printed into the plot. Similarly, I could do multiple points. So I could actually follow my points here. I could do control versus treatment. I could give it some letters to plot. And we already saw letters comes with R. It gives you just all the letters in a vector. And then I'm going to tell it color blue. And I'm going to add one last parameter we haven't shown you, which is adjust. Because if I just plotted the text over my points, it's going to look really ugly. Right? So I can say to it, look, adjust all these values by a certain number, and I can give it the X and Y to adjust by. So don't adjust the X, but -1, adjust it by -1, and it will move these points in a slightly it will adjust them by -1 versus the original bottom point. Yeah. Actually, I was going to show that, but no, just set it again. R-M-F-O-1-1. Something I was going to show because it's a problem. Everyone does this in the class. What? But yeah. The other thing, which is I've skipped shapes because I find that useless, but add line is really useful. Once you have a plot, you might just want to have a horizontal, a vertical line. This is my cutoff. Nothing below this counter, nothing above this counter. Okay. Or you might want a kind of intercept and a slope. So we can do that using this add line function. And we can, if we wanted a horizontal line, I just say H, so horizontal, the position I want it. So here I want it at 10. On the vertical line, I say D equals here 50. I'm going to do that a different color, a different line width. Giving it there. Finally, I got add line 0, 1, which is going to be my intercept and my slope. So it's going to intercept at 0, and it should be going up 1, 1. So 20, 40, yep. And then I'm going to control the line type. I'm going to make that 2, so it should be like a dashed line. So we can add just straight lines to our plot, and that's also very useful. Really nice. Shapes I'm going to miss. So you made your plot, and then you want to export it. Okay, so there are a few different ways to do this in R, and probably the easiest way. Oh my God, my computer's so slow. Easiest way is just to go export here, right? So we've got this plot, export, save as image. It's going to give you JPEG, whatever, save as PDF. Copy to clipboard, that's also kind of useful. I looked up how you can do clipboard and Mac as well. I'm going to say that again. Someone asked about it. So I'm going to save the image. It's going to take 10 minutes for it to load because my computer says, oh, no, here we go. So it gives me the option of what type I want. I think, I'm not super au fait with all the graphics, but generally you want something vector-based, not necessarily something like a PNG. You might want a JPEG or something. What's really nice is SVG and EPS, because you can take them into Illustrator and you can take apart the various components of it, which is really important. Because no matter how great these graphs are going to be, you're going to mess with them in Illustrator to make them a little prettier. So SVG, EPS both work really well. TIFF is probably the worst one because it's very hard to then take a TIFF and then manipulate it. But TIFF is full information. It's got a lot of information. We can also change things like the width and the height here, which is really important. If I want to make this wider, higher, whatever, and I can change the file name. And then I can change the directory I want to write it to. So I have full control over how and where I write my plot, what type here. But a lot of the time, you're not going to be necessarily sitting in R doing this yourself. When you get really good at R, you're going to be writing scripts and launching them, and they're going to make the plots for you. Maybe you're going to do 1,000 of them at a time. So you need it to be able to make these plots and save them to file programmatically. You won't be having that interaction. So one thing we can use is these kind of wrappers here, this BMP, say, or JPEG. And I think all the different types of file will have their own version of this. But really, they take the same kind of setup. They take the file name, where you want to write to, so the full path to the file, the width, the height you want. Okay, so RStudio, depending on your size of your window, right? But here you can set this up front, tell it the units, and then you can tell it things like the point size. So be careful. Units, this is pixels. If you set units to be inches, IN, this is going to be a massive plot, and they take up a lot of space. So be careful there. And things like, BMP will have specific options, which you can see like point size, but JPEG has more options because it also allows you to do some compression, like quality. And really the way of doing this is what you will do is you'll say BMP, and in this case, you'll just say the file. I could add the width, the height, the pixels, or whatever. I will do my plot here, right? And what this has done, this has opened up what is called a graphical device. It's opened up a device which is ready to write my BMP file. And then as soon as I've made my plot, I have to do dev.off, and it's going to close that device. Okay, if you don't write dev.off, your plot's never going to get written to file, which is sad. Okay. Same for JPEG, same for PostScript, which is also useful for things like Illustrator. PDFs are really useful, and I think they work well in Illustrator and Inkscape too. Generally, one of the things you really want to set for PDF is the type. I think paper is the default, but here you can say paper equals A4, and it's just going to give you a sensible size. But like with all things, again, you need to do dev.off. Otherwise, it's just going to keep it in your local session. It won't write it to the actual PDF. Okay, so that's the end of our base. That was a little longer than I thought it would be. We have some exercises here. And we have the answers on the other thing. I'm going to have to take a little break, I think. It's a lot of talking. How long do you guys want to break? Do you want to grab a coffee? Yes, a lot of nodding coming. How long do you guys want? Just shout out numbers. 20. 20? Are we okay with 20? Let's do 20. Any questions? Obviously, ask me. I'm really happy. Oh, yeah. I will show your MF.